network. In the previous episode, we were discussing about the fundamentals of software processes, or we have four fundamental software processes. That is specification, which is related already the requirement determination, and also again we have software development. It is already associated with the software design and implementation. That is, software is converting into executed system phase. And again we have the software validation. This means already the software going to be testing or checking against the system specification and the software expectation from the users. And finally we'll have the software evolution. Evolution means already the software can be modified, repaired, or updated due to some reasons. So this was the previous day or the previous episode of lessons. Please share, subscribe this YouTube channel if you need more about software engineering. Simply let's going to discuss about the software specification. When we say a software specification, it is already we are going to talking about the requirement determination, or we are going to determine the requirements. So the system will have different kinds of service and constraints. Here as a software engineer we have to determine those requirements and services. So when you say software specification, it is a process of understanding and defining what services are required from the system and identifying the constraint on the system's operation and development. Don't forget that system service means at the end of the day the system will provide a certain functionality. This function is identified here or considered here. So we will define what are the services of the system or what are the system services are. And also during the software production there are different kinds of constraints. For example, we said that previously it is organizational constraint, schedule constraint, and financial constraint. So we will determine which constraint will face. In general, the software specification leads us to produce a requirement document. This requirement document will have a set of requirements, which is the defined requirements, and collectively this requirement already represented in a specification system specification models. These are the steps. We have 4 steps to process the software specification or to conduct the specification. The first one is already the feasibility study. The second one is requirement listation and analysis. The third one is requirement specification, and finally we have the requirement validation. So this is the steps or the stages that we are going to follow during the software specifications. Plus, using these two steps, the previous steps, we can produce 2 documents. The first document is already end user and customer document. This document is already represented by natural language and different diagrams for the user's understanding purpose only. Then the other document is the system developer's document. This document contains the sets of requirement which is considered as the system service. So it is represented by in detail through the system specification. So we are going to develop these 2 modules in this software specification phase. Let's see each steps of software specification one by one. When you say feasibility study means we are going to determine whether the system is worthwhile or not. So in different circumstances like economically whether the software worthwhile or not, politically, socially, or technically, operationally, we have to check whether the software is worthwhile or not, because every system begins with the feasibility study, or before constructing a system we have to conduct a feasibility study. Unless and otherwise the system cannot be worthwhile. So when you say feasibility study it is an estimate made of whether the identified user needs may be satisfied according to the current software and hardware technologies. So we have to check whether the software is implemented by using the current technologies, maybe it is software or hardware. On the other side, when we say feasibility study, we are going to check the effectiveness, the cost effectiveness of the proposed system according to the business's interest or business point of view. So this is simply what is cost effective means. The other thing, we have to check whether the current allocated budget is enough for software production or not. So if it can be developed with existing budget or budgetary constraint, we say that the software is feasible. You see, one, we can be check, can we implement the software using the current technologies? Is that cost effective? Or can we develop the software with the allocated budget. So these are a few of the feasibility study types. So it could be economical, technical, technological, organizational, and local, political, legal and social feasibilities. So we have to check these feasibilities. Keep in your mind, so when we conduct the study of the certain system as feasible, means it is okay, so we can proceed forward, unless and otherwise we will to back again and check and recheck again. So the second phase of software specification is already requirement listing analysis. In this part of the software specification process, we have to check, or we have to gather what are the requirements. So this is the process of deriving the system requirements. So observing the system and discussion with the potential users and procurers, and we are going to analyze the task, who are the roles, who have the roles, or who are the members in certain task, what will be the flows of the process, what kinds of input the task will take, and so on. So we'll check what kinds of tasks are there very well. So here we are going to gather the requirements from the business operating environment, from the current operating environment. So keep in your mind that there is already a requirement on our hand. So what's next? So we are going to translate this collected data or collected requirements in sets of requirements. This requirement can be the user requirement or a system requirement. So when we say requirement specification, we mean that translating the information gathered during the analysis activity into documents that define sets of requirements. So here this document will contain a set of requirements. These requirements later on will be the system service, or it could be the system's function at the same time. Maybe it will determine the non-functional requirement. That means the quality or the performance of the system requirement. In general, we have two types of requirement: the user requirements, which is written by natural language and diagrams. The system requirement already, this is the intended quality of service of the system. So we have to check that the system has its own quality. At the same time, it also has its functionality requirements. When you say the functionality requirement, this is the function of the system or a service provided by the system. It yields observable result. So basically, the system is built based on this functional requirement, or at the end of the day, this functional requirement will be achievable by the system developers, unless and otherwise the system cannot be worked, since we will gather different kinds of requirements from this system. So our intention is to computerize the current system into the new proposed system. So we have to make sure these functional requirements are maintained. The other one is the non-functional requirements. So these requirements are involved in system building indirectly. In case we can say these are the design goals, every design is based on this, or every design are targeted to bring these goals as the system performance and individual criteria, maintenance criteria, dependability, hardware and software requirements. So in general, the system requirements are related with the quality and the service of the system. Whereas having in mind, we will specify or we will define sets of requirement. What's the next is already requirement validation. Here in this part of the software specification, we are going to check whether the requirements are complete, consistent, and based on the realities. So this activity checks requirements for this realism, consistent, completeness. During this phase, we are going to find or discover different kinds of errors. If there is error, so we are going to modify, or we are going to modify it to correct these problems, unless and otherwise, if we move to the next stage with a lot of errors, we will cost them more. We will cost them more. It is the most expensive error that we commit in software production. So this part already checks whether the validity of the requirement according to the user's interest or the user's requirement, and do we all requirements are gathered and specified correctly, as well as inconsistent, as well as based on the realities. In general, this is how the software specification looks like. Diagrammatically. Finally, we'll have this requirement document. This requirement document will define sets of requirements for the system production or for the software production. It includes both the functional and non-functional requirement, the user requirements too. So this is how the software specification will be conducted. So don't forget that if you finalize the first software process, we have the system specification model. So we have to convert those specification model into software functions and software structures again. Here we have the software design and implementation, or in general we call it software development. Software design and implementation is the two phases of the two sub-phases of the software development. So the software design, in this design we are going to describe the structures of the software, the data models, and the structures by the system, including the algorithms. So generally we have to design algorithms for each component. There is the interaction or the relation between each component. We will also design, or we will also say something about those particular interactions or communications. Plus the system has its own structure. This structure is considered as part of the system, or it is considered as a component. So we will also check what kinds of interface or interactions between those components. Having finalized the software design, we also change the system specification into executable systems. That means we are going to write different kinds of programming codes, or we are going to write different kinds of codes. So overall, the software design implementation is all about this. During the implementation, or the system being to be an executable system, because we will convert the system specification into the executable systems. Overall, the design part is looks like this, or in the designing part. So we'll do this. Having in mind, we will have the design inputs. This input is already from the RAD document, so you have to understand the RAD document very well. You have to understand the RAD document very well. From this RAD document, we'll design the architecture of the system, or architectural design, interface design, and component design. Also, we'll know that's what kinds of database to be designed. So this requirement document is already the basic thing. So this is we will take this as design input, and there are different kinds of design activities. These are the design activities. So this design activity will have the deliverable or the milestones for the next process. That means for the software for this. So this will be input for this. Here the database design, the interface design, the component design, and the database design also have produce the database specification, the system architecture, the interface design, the component design, and so on. In general, if you know what specify a specification you will have, so it's easy to design the software components as well. Keep in mind, here is from the RAD document. Here is from the RAD document. So when you say requirement specification, there are a set of requirements on RAD. That means requirements analysis document. So from this RAD document, we can design or we can process different kinds of design activities like architectural design, abstract specification, interface design, component data structure, algorithm activity will be proceed. So this activity also has the design products or outputs. For example, from the architectural design, we can understand what kinds of system structures we'll have, or how the system component will be deployed, and how the system structure will be considered to be already originates from this architectural design. And each design has its own outputs or deliverables. Keep this in mind. So we will design everything based on the design activities. Finally, this design result or product will be as input for the coding or for the implementation part. The other thing is already the software validation. The software must be validated, unless and otherwise the software product will be useless, because it should be validated by the user, or it should be validated by the system customers. So at the phase we have to do this. We have to conduct some tasks, or have to process some tasks. So the software validation. When you say the software validation, it's intended to show that whether the system confirms or conforms to its specification. In the software specification part, we will specify something. there are a set of requirements, so we have to check if we have maintained those requirements at the end of the day. The other thing, the users expect more from the system, so the system will be implemented on the user side, or the user have meet their expectations. So we have to check whether the system is meet this expectation or not. In general, the software validation is checking or testing the software from the requirement definition to program development. So previously in the software design and implementation, we developed something. We designed the structure of the software, plus we were designing the algorithms, and in the software specification part, we also specify the sets of requirement. So we have to check that if those requirement is answered by this software development process. In general, we have three types of software validations: the component testing, the system testing, and the active testing. Overall, we have to check whether the system is working according to its specification or the user's expectation. The other thing is the software evolution. In one or another way, the software may be modified, or there may be changes inevitable in software production. So we have to check is there changes raised or not. So change can be made to software as the time goes, as the technological advancements already due to the technological advancements, the demand of the customer, if there is a new emerging requirements. So at this time the software may be evolved, or the software may be modified, updated, or may be repaired. So this is part of software evolution. The existing system is assessed. If there is a change will be proposed and the system modified according to the needs of the change. So this is the last software process element, or this is the last software evolution is the last part of software process. That means change is inevitable always, because the customer will have new requirements, so we have to incorporate it. Maybe the customer may need new features, we have to update it. Maybe there is some failures, so we have to repair the software as well. So in this case, we have to follow this step. In the first thing, define the system requirement. Which part of the system needs change? So we have to define the system requirement. It's better to assess the system, propose the system change. Finally, you have to modify the system, implement the new systems. Overall, the software evolution is related with the system modification. So the existing software may be once upon a time, or in the future may be outdated, or it may be it needs a change because of the technological advancement and because of the new requirements. So the software will be changed. So this part is also enables us to modify the software products as well. Thank you very much. If you have any comments, please leave on the comment box, and like, share, and subscribe this YouTube channel to know more about the software engineering.